In this next question, we have 4 alcohols. So they are structural isomers, so compounds with the same molecular formula but different structural formula. And these are C4H10O. So 4 carbons, they are 4 carbon alcohol. You should be able to draw or sketch for all of them. And we'll be able to do this with skeletal formula. That is the fastest and the most elegant way to do any sort of A-level organic chemistry. The alcohol A does not react with acidified potassium dichromate. We know that that is an oxidizing agent. So the fact that alcohol A does not react, this straight away tell you that A is tertiary alcohol, cannot be oxidized. So that's something that you have to consider from the very beginning. B, C, and D can be oxidized, so they are either primary or secondary alcohol. Now, all 4 alcohols react with hot concentrated sulfuric acid. In this context, what you're going to get is this C4H8. So this is an alkene. So we are not sure about what kind of form it is yet. But this thing is acting as a dehydrating agent. So what you could do is you could use hot concentrated H2SO4 because you need to remove the H2O in order to generate the alkene, getting you back the double bond, carbon-carbon double bond. So you would do this at around 200 or 300 degrees Celsius. You'll be passing out the water as steam. Now A, C, and D each give you a single product in this reaction. But what is important is you have B giving you a mixture of 2 structural isomers, one of which, so out of the 2 structural isomers, one of them shows stereoisomerism. When you have alkenes and stereoisomerism, based on the definition that we had in the earlier questions, stereoisomerism is broken down into the optical isomerism with a chiral carbon. That is less likely given that you have 4 carbon, but we'll check in a bit. But the other thing you have to consider when you have carbon-carbon double bond alkene chemistry, it could also be cis and trans, which is geometric isomerism. What is very important in this question, they bolded it for you, give the skeletal formula. In fact, I was going to do a skeletal anyway, because if you watch all my other topical playlists with organic chemistry, you know that I'm a big proponent, meaning to say I support students learning skeletal formula, because when you go to A2, there's no other way except for skeletal formula. Now, what I'm going to do first is I'm going to draw out I'm going to sketch out actually all the structural isomers as well as probably even the stereoisomers for this C4H10O 4 carbon alcohol. C4H10O it's got a alcohol, so it's a 4 carbon alcohol. We knew that just now A is a tertiary alcohol, but what I'm going to do is I'm just going to draw straight chain first, 1, 2, 3, and 4. You will see that this is CH3, CH2, CH2, CH2OH. You will see that 4 carbons, 3, 4, 5, 6, 7, 8, 9, and 10, and 1 oxygen there. So straight chain alcohol there. This thing is what you call butane 1-ol. So this is butane 1-ol. Now that is definitely one of the isomer that we can have. What else can we have is we can have actually I'm gonna move around the OH first, so we can have butane 2-ol like that, 1, 2, 3, and 4. So this is a secondary alcohol now, because if you look at the carbon with the OH, the carbon with the OH now is bonded to 1 and 2 other carbons. It's a secondary alcohol. So 2 degree there refer to secondary alcohol. Butane 1-ol is a primary alcohol because the carbon bonded to the OH is bonded to 1 other carbon. Now the next one, which I can have, well, you might be thinking about this. You might be thinking about 1, 2, 3, 4. But you must also consider the lowest number for the important carbon, which in this case is the carbon with the OH. 2 is smaller than 3. And when you go that way, that is not different from this because that is still butane 2-ol. So that is the same as that. So we don't consider that at all. But when I go back to the original 4 carbon here, butane 1-ol, we can see the 4 carbon straight chain here. We can branch out the straight chain. So what I could get is I could get still the straight chain like that, but now I have 3 carbons, 1, 2, and 3. Where can I put the extra CH3? Well, I can branch it out. So this is a branch chain. This is a straight chain. Between 1 and 3, the relationship is straight chain and branch chain. So this thing, they are what you call chain isomer. Whereas the relationship between 1 and 2, so butane 1-ol and butane 2-ol, as you could see from the name itself, this thing is what you call positioned isomer. The other one included under structural isomer as is what you call functional group isomer, but we're not gonna do functional group isomer here because we are told specifically that these are all alcohols to begin with. So what do we have here? This thing is got a chiral center. What else can I say? Straight chain, branch chain. Oh yep, I think I'm missing the tertiary alcohol. So this must be the tertiary alcohol. The carbon bonded to the OH is bonded to 1, 2, and 3 other carbons. So there are 4 carbons, 3 hydrogen, 3 hydrogen, 3 hydrogen. Carbon from 4 bond, you only show 1 bonded to the carbon, 1, 2, 3 hydrogen. Carbon from 4 bond, 1, 2, 3 hydrogen. Carbon from 4 bond, 1, 2, 3 hydrogen there. And another hydrogen there, so 10 hydrogen. This is your tertiary alcohol, which means this must be A, because A there was your tertiary alcohol that cannot be oxidized by this K2Cr2O7 H plus acidified there. So that is the skeletal formula for this tertiary alcohol. B is the one that when you dehydrate, when you remove the H2O, it's going to give you mixture of 2 structural isomer. The structural isomer in this C4H8 is the one that will show stereoisomerism. So they were not asking for stereoisomerism in the alcohol itself. Be very careful. What I'm going to do now is I am just going to remove the, maybe not, I'm just going to move up the name so that I can make you see what's happening when I remove the hydrogen and the OH there. So when I remove that, what I get is just one product there. When I remove here, you can see that I can have this hydrogen removed from carbon 3. Then I could get this product. But then, this is a trans isomer. I could also get cis isomer like that. And you could imagine that there is actually another one. So, not a good color to choose. Let me choose this black color one. So, if you see this black color carbon, you will see that there could be an alternative hydrogen on the other side. This is a CH3, this is a CH2. They are different hydrogens, which is why they will give you different product. So altogether, you get 2 structural isomers, but one of the structural isomer shows stereoisomerism, which is your cis and your trans. The cis, they're on the same side, the trans, they're on opposite side. How about this one? This one here, you can eliminate from there or there. It's just going to give you the same product because this CH3 is the same as that CH3, is the same as that CH3. They are symmetrical. They're going to give you one product like that. And how about this one? This one is also going to give you just one product because on the next carbon to the carbon with the OH, there's only one hydrogen. So it's just going to give you one alkene product like that. And that product is the same as that. Doesn't matter. This is the one where it was quite special. That must have been B because B is the secondary alcohol, is the one that gives you 2 structural isomers, one of which show you stereoisomerism, in this case the cis-trans geometric isomerism there. So B has to be the secondary alcohol, the butane 2-ol. If you look at this straight chain and this is branch chain, so this is very clearly what you call chain isomerism, straight chain versus branch chain there. What else can I say? Can I say anything about C and D? There's no other information given for C and D, so I guess I could put C the straight chain, for instance. Doesn't matter which one you put as which one, I think, because you're gonna relate them in the end anyway. 1, 2, 3, and 4 like that. Perhaps can remove the number actually. 1, 2, 3, 4, and then the last one is going to be the straight chain, but then being branch. Well, that doesn't make quite much sense. Nope, that is wrong, I think. Is that wrong? 1, 2, 3, 4. That is butane 2-ol. What I want is this thing here, so I don't want that. I want this thing here, where the CH3 is at this position here. Then this is branch, because this one, the name is going to be 2-methyl propane 1-ol. Whereas previously we have 1, 2, 3. So we have 2-methyl. And this is propane because 3 carbon longest chain. This is propane 2-ol. So these and these, they are what you call position isomer, as you could see the 2 and 1 there. And these and these, they are what you call position isomer, because this is a position 1, 1, 2, 3, 4. But this is 1, 2, 3, 4. This is butane 2-ol, whereas this one is butane 1-ol. So what we get really is these are related together. These are your position isomerism there. What else? Straight chain, branch chain. So again, that is your chain isomerism. We don't talk about functional group isomerism here because they are all alcohols. So it's not like they are gonna have other functional group other than alcohol. So we don't talk about functional group isomerism, which actually comes under structural isomerism. So typically you talk about structural isomerism and functional group isomerism, specifically when you have aldehydes and ketones. So those two are put together as a topic. So aldehyde versus ketones, they are functional group isomers. And then you have another one, which is carboxylic acid and also esters. So those are functional group isomers as well when you have the same number of carbons. Anyway, is that the end of the question? Not really. There was just 7 marks. We also have this next page there. So give the names. They want the names of the 2 structural isomers produced by the reaction of B with the hot concentrated sulfuric acid. So the 2 structural isomers are these, not these and these, but these and these. So this is 1, 2, 3, 4. So this is what you call but 1-in for the black color one on the far right. But 1-in, the lowest number for the alkene. And then both of these, they are called but 2-in. This is cis but 2-in. This is trans but 2-in. So give the names for both of them. So the other one is but 2-in. I think there is a space there, so I'm supposed to fill the space there. Now state which of these isomers show stereoisomerism, and then explain why. Okay, so it's going to be this isomer, which is but 2-in. So I already identified that, so that is just the first bit. Now explain why do they show this particular stereoisomerism, cis and trans there. So the presence of the double bond, the presence of the carbon-carbon double bond that prevent or they restrict rotations, that prevent or they restrict free rotations about that carbon. Okay, so meaning to say you cannot rotate from this to the other one freely about this carbon-carbon double bond, the pi bond there. And we also have different groups, the second conditions. So, and there are different groups. The second condition is something that a lot of students always miss out because they thought just because you have double bonds, you will have cis and trans. Not really. You must also satisfy the second condition. You must have different groups. Well, not really different group. You must have, you must not have the same group on the same carbon of the carbon-carbon double bond. In this case, for instance, this one, you have 2 groups that are the same on the same carbon of the carbon-carbon double bond, so you don't get cis and trans there. But here, the groups are on the different carbon, so you get different groups on the different carbon. I think the different carbon of the carbon-carbon double bond is really, really important because there's a second condition for you to get the cis and trans isomerism there. Last but not least, I think that's the end of the paper and the question actually. Draw display formula. Display means show all the bonds. So do not forget that you need to show all the bonds for display formula for these 2 stereoisomers. So remember it was but 1-in as well as but 2-in earlier. So I'm just going to show but 1-in first. So carbon-carbon double bond and then like that. And then put in all the hydrogen. So C4H8. Carbon form 4 covalent bonds. Carbon form 4 covalent bonds. So make sure you count carefully. 1, 2, 3, 4. So only 2 hydrogen there. Carbon form 4 covalent bond. 1, 2, 3, 4. So there's only 1 hydrogen there. Carbon form 4 covalent bond. I'm still missing 1 hydrogen there. So be very careful. So count all together. 1, 2, 3, 4, 5, 6, 7, 8. C4H8. Now I have Nope, I have done a mistake. This is not the cis and trans because this is stereoisomerism. I don't know why I did that. We have to draw the cis and trans actually. So not build one in, but build two in. So you gotta draw the cis and the trans. So let's go back and backtrack on what I said. So that is like that. And we have a cis, so there's CH3. And they are on the same side of the carbon-carbon double bond. And this one has to have the hydrogen there. You can also count 4 carbons, 3 hydrogen, 6 hydrogen, 7 and 8 hydrogen. I'm going to do the same thing on the other side, but I have to have the CH3 on the opposite side now for me to show the trans isomer. They don't specify that it has to be cis here. You can draw the trans here and the cis here. As long as you show all the covalent bonds, you will be fine, and not to make the mistake that I made earlier and drew build one in, because build one in doesn't have the stereoisomer. It's the build two in that shows the geometric, which is the cis trans isomers as stated in the S syllabus. Okay, that's it really for this 30-mark question. And I think that's it really for this whole paper. So thank you for watching, and I hope that silver membership will have been worth it, because there'll be more and more tutorials added in the future as well on a weekly basis. And it's for a cup of coffee to support my work. And if those are useful, don't forget to check out the topical playlists. They are available for free as well. So do share the channel, do share the playlist, the master playlist link with all your friends, relatives, juniors, seniors in schools, etc., and hopefully it will help other people as well. Thank you for watching. I'll see you in the next tutorial video. Don't forget to click the button on the bottom right before you leave, like the video, share the video, or in general just spread the words about the channel, and follow me at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. Thank you for watching again.